Good afternoon, students. Today, we are going to discuss one more topic called Association Rule Mining, which is a part of Module 4. Let us start with the introduction. Association Rule Mining. As the name suggests, association rules are simple if-then statement. I repeat, association rules are simple if-then statements that help discover relationship between seemingly independent relational database or other data repositories. Most machine learning algorithms work with numeric datasets and hence tend to be mathematical. However, association rule mining is suitable for non-numeric categorical data and requires just a little bit more than simple counting. Association rule mining is a popular unsupervised learning technique which is used in most of the businesses to help identify shopping patterns. It is also known as market basket analysis, which I am going to elaborate in the next slide. What is market basket analysis? The main aim of the association rule mining is cross-sell related items and to increase the size of the sale, thereby the profit of the organization. As I told, the association rule mining technique, the data used can be categorical, okay, and also it supports the numeric dataset also. And here, one thing to observe here that in association rule mining, there is no dependent variable. When I say dependent variable, as we saw in the classification and regression, we had a training data, test data. Training data had a target variable, which is also called as dependent variable. So we used to train the model using the training data. Then we used to check the accuracy of the model using a test data. So we had one concept called class label. That class label is not there in the association rule analysis. Okay, this association rule analysis uh, is does not have dependent variable. It accepts input, okay, as in the form of a transaction data, and it will provide output in the form of a description of most frequent affinity among the items. So I can say association rule mining is a procedure which aims to observe frequently occurring pattern, correlations, or association from data sets found in various kinds of databases such as relational database, transaction database, and other form of repository. Say for example, if I uh, take an example that if a customer buys bread, he is 70% likely to buy in milk. So here, 70% likely to buying milk. That means there is an association between the bread and the milk. 70% of the customer who buys bread also tend to buy the milk. Another example here it is given. A customer who bought a laptop computer and virus protection software also bought an extended service plan 70% of the time. That means the customer who buys a laptop computer and the virus protection software also takes extended service plan 70% of the time. Okay, so this correlation, laptop virus protection software and the extended service plan, there is a correlation among these items. That correlation is identified using the association rule mining. Now let us discuss some of the business applications of association rule mining. In business environment, a pattern or knowledge can be used for many purpose. Okay, say in the field of sales and marketing, it is used for cross marketing and cross selling of the products. Also used for catalog design, e-commerce site design, online advertising optimization, product pricing, sales promotion configuration, like this. This association rule analysis suggests not to put one item on sale at a time and instead to create a bundle of products promoted as a package to sell other non-selling items, which is having a less demand. Okay, they can offer a discount and put with the they can keep along with the items which goes or which is purchased frequently. That is the idea. In the retail environments, it can be used to store design. Strongly associated items can be kept close together for customer conveniences, or they would be placed far from each other so that the customer has to walk the aisles, and by doing so is potentially exposed to other items. That is the idea here. Okay, so when they walk, they see many items kept in the rack, so they also feel to take the items. So along with the regular item, new items may also get sold. In medical diagnosis, these techniques can be used for relationship between symptoms and illness, diagnosis and patient characteristics or treatments, gene and their functions. For this all things, it can be used. Let us discuss more on market basket analysis. Market basket analysis is one of the key techniques used by large retailers to uncover associations between items. It works by looking for combinations of items that occur together frequently in transaction. Okay. To put it another way, it allows retailers to identify relationship between the items that people buy. Say, for example, a customer who buys bread, there is a chance the customer also buys jam 70% of the time. Okay, that means there is a correlation between the bread and the jam. The customer who buys laptop, he has to take care of his laptop, he have to keep it safe. The customer is tend to buy laptop bag. That means a customer who buys laptop, there is a chance that 90% of the customer buys, there is a chance that 90% likely to buy the laptop bag. So there is a correlation among the bread and jam too, and there is a correlation among the laptop and the laptop bag. Let us take one more example. Suppose it is observed that there are out of 100 customer, okay, out of 100 customer, 70% of the customer will buy bread and butter together. Okay, bread and butter, both bread and butter. There are 100 customer. There is 100 customer or 100 transaction, we can say. Out of 100 transaction, okay, 60% of the customer, let us take 60% of the customer buys both bread and butter. So to increase the sale of other products, let us say egg. Okay, I should go. To increase the sale of the egg, okay, along with the bread and butter, if the market or supermarket give offer 50% offer on the egg and keep aside to the bread and butter, the customer obviously will think to buy the egg also, because 50% offer is given to the item X. So the customer who buys bread and butter, okay, also encouraged to buy the egg by giving the 50% discount. So along with bread butter sale, the sale of the egg will also be happening. Okay, so this type of analysis, they are finding the correlation, okay, or the relationship among this item set, okay, that we call it as a market basket analysis. Yeah. Here, association rule mining. So, given a set of transaction, this is a transaction database. Okay, remember we will be using the word transaction database. Given a set of transactions, we have to find the rule that will predict the occurrence of an item based on the occurrence of the other items in the transaction. So this we called as the association rule will be of this form. If a customer buys onion, the customer also buys juice. That means if the customer is a lady, if she has come to the market to buy the onion, supermarket to buy the onion, so if she finds the uh, juice next to it, okay, she may think if the guest comes, she can serve the juice for them. Okay, there is no actual relationship among the onion and the juice, but the buying pattern, maybe most of the there is a chance most of the customer, if the customer is a lady customer, then they think about if the guest is coming or the summer season, we can have the juice in the school. So when they when she has come to buy the vegetable, okay, she may buy, most of the time the customer may buy juice also. Okay, so there is a correlation among the onion and the juice. This type of association we find by using the association rule analysis. This we call as the association rule. So the customer who buys milk bread tend to buy eggs and coke also. The customer who buys juice and bread also buys the milk. So this type of association among the among the items, okay, in a transaction is found by association rule mining. So here one thing you remember, the implication means co-occurrences here, not the casuality. Okay, casuality. Casuality. That means like now let's discuss some of the important definitions or the terms used in association rule mining. First of all, item set. What is item set? A collection of one or more items. We call it as items. Say, for example, here we have in this example 5 transactions. Each transaction has a set of items. So transaction 1 is having a set of items like bread, milk. So this one whole together we call it as a item set. Okay. So milk, bread, onion. This we call it as an item set. The set of one or more items we call it as an item set. What is k item set? An item set that contains k items. So if the item set contains only 2 items, that we call it as a 2 item set. If the item set contains 4 items, we call it as a 4 item set. If the item set contains 100 items, we call it as a 100 item set. Next we have another term called support count. This you have to remember. Okay, in coming slides we will be using that. What is support count? The frequency of occurrences of an item set. Say for example, what is the support count of milk, onion, bread together? I'm telling about in the terms of together, milk, onion, bread all together. So here, milk, onion, bread, how many times it is occurring in the entire transaction? So milk, onion, bread, milk, onion, bread. So here, milk, onion, bread is here in this transaction. Milk, onion, bread, it is here in this transaction. Then here milk, bread is there, onion is not there. Milk, onion is there, but bread is not there. Milk, onion, juice is there. So how many transaction is having this combination? 2 transaction. So that we call it as a support count. Okay, the frequency of occurrences of an item set in the transaction database. Okay, this is transaction database, that is 2 here. Next we have Support. Okay, what is support? The fraction of transaction that contain an item set. The fraction of transaction that contain an item set. So we can say how often the item go together in the data set. Okay, how often the item go together in the data set. So if you take the support of this item set, that milk onion juice, milk onion juice, milk onion juice is here, milk onion juice and milk onion juice, two transaction out of 5 total transaction it is occurring. So two transaction is having this combination milk onion juice. Okay, so 2 by 5. 2 by 5 is the support. Okay, 2 by 5 is the support. Next, frequent item set. What is frequent item? We have item set and frequent item set. So item set is the collection of one or more items, whereas frequent item set is that there is one concept called minimum support. Okay, minimum support. What is that minimum support? That means in the business, okay, the marketing department may fix some threshold that out of 1,000 transaction, okay, 1,000 transaction, so 20% of the transaction should have this items sales. Okay, the combination of this item sale. Say for example, here only we can say that milk onion juice. The out of 5 transaction, the minimum 2 transaction must have milk onion juice. Okay, then only we'll consider that is a frequent item like that. So here an item set whose support is greater than or equal to the minimum support threshold. So we know what is support. Okay, we know what is support. So what is frequent item set? The item set which is having meeting the threshold, or which is having the support count. You know what is support count, and we know what is support. So which is having the support, and the item which is having the support more than or equal to minimum support. Okay, there will be a cutoff. Say for example, when you go to the placement, if you want to go to if you want to attend the interview of a Infosys, they will give the cutoff as 60%, say. Okay, for example, so 60%, those who have 60% and above, they will be allowed to take up the interview. Here also there will be so many candidate items. Okay, item set, so which are eligible, okay, which are eligible means more frequently purchased item. So to the cutoff will be kept. That cutoff, okay, is nothing but minimum support threshold. So this minimum support threshold. So those items set, okay, which is having the support greater than or equal to minimum support threshold, that we call as a frequent item set. So there is a difference between item set and the frequent item set. Okay, so remember. Next, so here we will be discussing on the association rule and the terms or the metrics of the association rule. So how to write the association rule? The general syntax of writing the association is like this: X tends to Y. Okay, it can be single line or double line, no matter. X tends to Y, and S%, C%. S% we called as a support, and C% is nothing but the confidence that we am going to tell now. Okay, where X and Y are products or item set. The association rule is the general syntax is like this to write the association rule. So X we called as the LHS, otherwise antecedent, and Y we called as a RHS, that is nothing but the consequent. Example, milk onion tends to juice. Milk onion is LHS, that is antecedent, and juice is consequent, that is RHS. So here in the association rule mining, okay, in defining the association rule mining, we have two metrics or a criteria, that is support and the confidence. In the last slide, I told what is support. Again, support is nothing but fraction of transaction that contain both X and Y. Okay, but that contain both X and Y. Say for example, here milk onion tends to juice. If I take this, okay, milk onion tends to juice, that means what? What is the support of this item set? Milk onion juice. Milk onion juice. That is 2 by 5. When I tell the confidence, okay, confidence, it is a measure how often items in Y appear in the transaction that contain X. That means how often the item Y, that is Y means what? RHS. Okay, is found given the X. Given the X means LHS, that is milk onion. So how often the juice is found when the milk and onion is purchased. Okay, milk and onion is purchased. Say for example, here we have the confidence. Confidence will be given as the formula. We have the formula like this. I'll write it out. So here the confidence, how we can find the confidence. The confidence will be like support of, okay, support of X union Y whole divided by support of X. That means here when milk onion juice, okay, is purchased, how often milk onion will be there in the transaction. So milk onion support of XY. X and Y is milk onion and Y is X is milk onion. Y is juice. So milk onion juice. Okay. Total number of transaction having milk onion juice whole divided by the support count of milk onion. So here milk onion juice. Milk onion juice is in the 2 transaction. And how many transaction is having milk and onion alone? Milk onion, milk onion, milk onion, milk onion. It is 1, 2, 3, 3. Okay, 2 by 3. 2 by 3 will be the confidence. Okay, when I take the support, support is just nothing but the total number of transaction. Okay, this is for the confidence, what I have written. So here the support count of how to find out the support count of milk onion juice. Milk onion juice, that is X union Y whole divided by N. Okay, I just write it support count. That is nothing but milk onion juice. Milk onion juice, it is 2 divided by 5. Okay, so this is the support. So here, this is how we create. That means support, you will remember how often X and Y go together in the data set. That is support. How often X and Y go together in the data set. That is support. Confidence means how often Y, okay, how often Y is found given X. Okay, how often Y is found given X. Okay, hope you are understood this. So this is what I just showed you. The support is 2 by, that is 0.4, and that is 4% we can say. Confidence is 2 by 3, that is 67%. Okay, that means when milk and onion purchase, there is a chance that 67% of the customer also purchase juice. Now, algorithm for association rules. So actually, the association rule mining is a two-step approach. So first we have to find the frequent item set, then we have to generate the strong association rule. So as I told, frequent item set. Whenever I say frequent item set, you have to keep in your mind there should be a minimum support threshold. So the item set which is having the support greater than or equal to minimum support threshold, we call it as a frequent item set. So first we have to generate the frequent item set using this condition. Okay, condition. Next we have to find the generate the strong rules using the confidence. Okay, so there will be a minimum confidence set. So the frequent item set here, when I come rule generation, we have to use the frequent item set. The frequent item set which is having the confidence more than or equal to the minimum confidence, then that will come under the rule generation. That will come under the rules association. We'll see with an example. Okay, so next we move on to a priori algorithm. This is one of the popular algorithm which comes under the association rule mining. This a priori algorithm is based on a principle called a priori principle. Okay, so what is that a priori principle? Please remember, if an item set is frequent, then all its subset must also be frequent. Say for example, if I say the item set, we have an item set A, B. This is the item set. What is item set? The collection of one or more items. So this is an item set. Then what is the subset of this item set? A and B. A and B. A is one item and B is another item. Okay. Similarly, if I take A, B, C, what are the subsets of A, B, C? A, B, B, C, A, C, A, B, C. Like that will be the subset. So what a priori principle says? If an item set is frequent, then all its subset must also be frequent. If AB is frequent, obviously A and also B frequent. Conversely, we can say like this. If an item set is infrequent, all its superset must be infrequent too. That means suppose A is a infrequent item set, then which is the superset of A? AB. So AB is also infrequent. AB, AC will also be infrequent. Okay. So who actually came up with the idea association rule mining? That is Agarwal and Shrikant. They published the paper in the publications. Okay, so what a priori principle is? Okay, what property the a priori principle is having? A priori principle holds due to the following property of the support measure. They are basically based on the support. So what it says, for all x and y, I told x is a uh, x and y both are item set. So if x is a subset of y, okay, then x support of x is greater than or equal to support of y. So what this property means? That means support of item set never exceeds the support of its subset. Okay, so x is a subset of y, then the support of x will be always greater than or equal to support of y. So the item set, okay, the support of item set never exceeds the support of its subset. This property we call it as anti-monotone property of support. Okay, anti-monotone property of support. Let's see with an lattice item set lattice. So if we take this item set lattice, okay, suppose we say if the item set is frequent, then all its subset must also be frequent. So let us take AB as a item set. What are the subsets of this item set? What are the subset of this item set? We have AB is a frequent, A and B are the frequent items. Then if AB is frequent, the subset A and the subset B is also frequent. Conversely, if the item set is infrequent, then all its superset must be infrequent too. Suppose AC I have taken as an infrequent item set. Okay. Then what are the superset? When I say infrequent, we have to consider the superset. What are the superset of AC? Superset is nothing but which contains AC. AC is here. So ABC, ACD, and ACE. Why not AB? Because it does not have C. So it will not come. So AC, it should contain AC both. So AC combination. So ABC, ACD, ACE. They also will be infrequent. Okay. So what is the advantage of this a priori algorithm is that we have the a priori principle which says that if the item set is infrequent, then all its superset must also be infrequent. That means instead of in a naive algorithm, okay, in a naive algorithm, in the item set lattice, that is, if there is a 5 items, then there will be 2 to the power of 5 candidate items that will be there. Say here you can see there is a 5 item, different item A, B, C, D, E, 5 different items. Then the candidate items set will be 2 to the power of 5, that is 32. 32 candidate item set will be there. So every time it will be scanned. So it actually the computationally it will be expensive. To reduce that, a priori algorithm has come with the a priori principle. The main focus here is to reduce the number of candidate item set. Okay, reduce the number of candidate item set. Why? By using what? A priori principle, saying that if the item set is frequent, then the subset is frequent. If the item set is infrequent, then the superset will be infrequent. So we can say easily eliminate it. So if the item set found to be infrequent, here suppose AB is the infrequent item. So obviously all its superset. AB superset is ABC, ABD, ABE, AC, ABCD, ABC, ABD, ABCDE. Everything will be infrequent. Then we can just prune out this. Okay, prune out this. So out of 32, instead of scanning all 32, we can just scan only 24 items. Okay, 24 candidate item set. Okay, why? Because the a priori principle, it will prune out the infrequent item set. So here you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 is pruned out. So no need to. It has been eliminated from the frequent item set. Eliminate from the candidate item set. Candidates. So only 24 need to be scanned. So it is actually the computationally it has become comparatively the naive algorithm. It has become less computationally. It has the computational power has been reduced. Okay. So next, how the a priori algorithm will work. So it is basically a candidate generation and test approach. Generate candidate and test. Okay, generate and test approach we say. Okay, that is a priori algorithm. Generate and test approach. So what we have to do here in the a priori algorithm, the steps is given like this. First, initially we scan the transaction database to get the frequent one item set. When I say frequent one item set, the item set which is having only one item at a time. So then we generate the length k plus 1. So here k is equal to 1. K plus 1 means 1 plus 1, 2. 2 candidate item set, 3 candidate item set, 4 candidate item sets, and so on. So first we generate k plus 1 candidate item set from length k frequent item set. Then what we do, we test the candidate against the database for its minimum support. Then terminate when no frequent item or candidate set can be generated. Terminate when no frequent. That means we stop when there is no further frequent or candidate item set. So it will be more clear for you when I take up the example. So let us take this one example for understanding the a priori algorithm more clearly. Let us take this transaction. Okay, I've gone through this transaction. I've taken this example because it covers all the possibilities. Okay, to solve the problem. Okay, so we have a transaction ID 1 to 9, and we have a list of items. So if you observe this list of items out of 9 transaction, you can see there are 5 different items. Okay, 5 different items. So this is a transaction database which is given at the name D. Okay, which consists of 9 transactions. Suppose minimum support count. The minimum support and minimum confidence will be given. Minimum support count is 2. Okay, so the percentage of minimum support will be 22. How? 2 by total number of transactions, that is 22%. So let minimum confidence required is 70%. Both are given here. Okay, minimum support is 2 and the confidence is 70%. So first what we have to do in the a priori algorithm, we have to find the frequent item set. Then the association rule. That's why I told in the previous slide, it is two-step approach. Two-step approach means what? First step, we have to generate the frequent item set. The second step, we have to generate the association rule. We call it as a strong association rules using the metrics called support and confidence. Okay, hope you are understood. We'll start with the first step, that is generation of frequent item set. So first step, we have to generate one item set. Okay, one item set frequent pattern. So first we have a transaction database. We will scan the database to count the occurrences or frequency of each item. As I told, there are 5 different items: I1, I2, I3, I4, I5. So if you observe this entire transaction, we have 5 different transactions. items and in the entire transaction. So here, first step, we will, this is the original database that will not be changed. Okay, remember. So first we scan the transaction database D and count the occurrences of each item in the database. So we have 5 different. So I1, I2, I3, I4, I5. So this we call it as a candidate item set. C stands for candidate, L stands for frequent item set. As I told, there is a difference between item set and the frequent item set. Item set, candidate item set. Item set is nothing but one or more items. But when I say frequent item set, you should remember that the item set support should be greater than or equal to minimum support. Already here already a minimum support value is given. What is that? 2. Okay, so the item which is having the support count greater than or equal to 2, that will become the frequent items. Okay, these are the candidates from the database. So what is the support of this each candidate from the database? Item 1 is occurring 6 times, item 2 is occurring 7 times, item 3 is occurring 6 times, item 4 is 2 times, item 5 is 2 times. So we have found the support count. This is candidate. Okay, then we have to compare candidate support count with the minimum support count. What is the minimum support count? Minimum support count given is 2. Okay, minimum support given is 2. So let us see, is there any candidate which is less than or less than 2? So it is greater than 2, 7 is greater than 2, 6 is greater than 2, item 4 is having 2, 2 is equal to 2 and 2 is equal to 2. So all items have the minimum support. So all items will become eligible for frequent item set. L stands for frequent item set. Okay, frequent item set. So remember, C is candidate item set, L is frequent item set. When I say frequent item set, it should be the support count should be greater than or equal to minimum support. In this example, the minimum support given is 2. Okay, hope it is clear for you. So first we found out with the minimum, we found out with the frequent item set. Frequent one item set. One means one items. Okay, one item in a item set. So we came up with the L1. So we generated L1. Then again, next what we'll do, we have to move to the next level, that we have to generate k plus 1. K is equal to 1 now, one item set. So k plus 1, we have to generate k plus 1 item set. That is k plus 1, 1 plus 1, 2. That is we have to generate the 2 item set. So 2 item set, we do that by using a operation called join operation. Here in a priori algorithm, we have 2 operations. That is, one is join, another is prune. Okay, we are using 2 operations here in a priori algorithm. One is join, another is prune. Okay, we use prune. So these are the 2 operations we have. Okay, so using this, we'll join the frequent item set L1 join L2. How we'll join? L1 is joined by itself. So when we join L1 with L1 itself, you can see here I1. I1 union I1 is I1 itself, so it is not joined. I1 is joined with I2, I1 is joined with I3, I1 is joined with I4, I1 is joined with I5. Likewise, we keep on doing for every item. Okay, so L1 join L2 will produce a C2, that is candidate 2. Candidate 2 means what? It is a set of item set which is having 2 items at two items in the item set. So here we can say I1, I2, I2, I1 both are same. So we can keep one occurrence. So I1, I2, I1, I3, I1, I4, I1, I5, I2, I3, I2, I4, I2, I5, I3, I4, I3, I5, I4, I4. These are the set of candidates, okay, which is formed after joining the L1 by itself. So this is candidate 2. Okay, we have gone to the next level. Okay, so this is a level-wise algorithm. Okay, and we use this in a recursive manner. So level-wise algorithm. So what we are doing, this is the original database. So from joining L1 by itself, we got the candidate. Now we have to check, okay, we have to scan the database and we have to count the occurrences of how many times I1 and I2 are purchased together. So I1 and I2 here 1, 2, and 3, 4, 4 times. So we have taken the support count of each candidate two item set. So candidate two item set, we have got the support count. Now next we have to find out the frequent item set. Okay, that is L2. That is two item set, frequent two item set. So what is the condition? The support count of this item set should be greater than or equal to 2. Minimum support count, that is 2. So 4 is more than 2. Okay, so item 1 and 2 together is having support count more than minimum support count. Okay, this is get selected, but this will not get selected. Okay, and this will be get selected, 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 and this 3 will not be get selected because it is having the support count less than minimum support count, that is 2. So only this many items will be selected, that we called as a L2. Okay, so these are the frequent item set. Two frequent two item set. That means two items in an item set. Next we have to go for L2 into L2. We have to do L2 into L2. So when we join L2 into L2, okay, so when we join L2 into L2, we'll get the three item set. Okay, so why here we have six candidate three item set. Okay, candidate three item set, but I have taken only two here, not three, before finding the frequent item set. Why is because, as I told, in the a priori algorithm we have two steps. We perform two steps. One is join. Okay, that we have done. Candidate L1 into L1 we have joined, which is resulted in L2 L. Okay, then we have to prove the second step, that is a priori principle we are not yet used. I think you remember what the a priori principle is. A priori principle is what that if the item set is frequent item set, if the item set is frequent, then all its subsets are frequent. If the item set is infrequent, all its supersets are infrequent. That is the a priori principle. Till now, we have applied first step operation, that is join operation. L2 is that is C2 is formed by joining L1 and L1. Yes or no? And C3 is formed by joining L2 into L2. So when we joined L2 into L2, we got this. Okay, we got this C3. Hope you have understood how we got mm, the how we got the L3. We joined this, combined this. Okay, we joined this L2 into L2, I1, I2, I1, I3. So I1, I2, I3. We got like this. Okay, so we'll see how frequent it is. So here, yeah, it is in detail here I have given. So C3 we have got by joining L2 into L2. We are joining L2 into L2 again. So we'll get that I1, I2. This is the set. So this is I have given here. Okay, you can just have a look into that. Now, out of this, okay, this many candidates are there. Now we have to make sure, okay, we are applied the a priori principle. That means all the item set, three item set are frequent or not. Okay, so here we'll take the second operation, that is prune using the a priori principle. That's why if you see in this example, okay, candidate we have 6, but in that candidate also I have selected only 2. Okay, before going to the frequent item set, candidate out of 6 only 2 has been considered. Okay, even though this have the it may have the minimum support, but it is not considered. Why? Because there is a it is violating the principle, a priori principle. Okay, that we take. So we'll use the a priori property to prune the item set which is not frequent. So let us take this example. So I hope you have understood. By joining L2 and L2, we do like this and we'll get the item set. This is what I am written here. So here we have to see whether this item set are frequent or infrequent. Okay. So here let us take I1, I2, I3. What are the subsets of I1 and I2? I1, I2, I1, I3. So I1, I2, I1, I3. So now all two item sets of I1, I2 are members of L2. Yes, on I1, I2 is there also there. I2, I3 is also there. They are the members of L2. That means frequent item set, frequent two item set. So I1, I2, I3 is in C3. That means what? That means what? Here I1, I2, I2, I3, I1, I3. One second, I take the marker. So what are the subset of I1, I2, I3? I1, I2, I1, I3, I2, I3. Okay. I1, I2, it is present in L2. It is a frequent item set. I1, I3 is also present in L2. It is frequent item set. I2, I3 is also present in L2. It is also frequent item set. That means what? If it is a frequent item, okay, then its superset is also means its subset is since it is a frequent, okay, then I1, I2, I3 subsets are frequent. Okay, subsets are also frequent. So it will be obviously it is a frequent item set. So I'm coming to this. Okay, if you take I1, I2, I5, the subset of I1, I2, I5 is I1, I2. It is present here. I1, I2. Yes, I1, I2 present here. Then I1, I5. Yes, it is present. Then I2, I5, yes, it is present in the L2. So all these are frequent. Then I1, I2, I5, I5 will also be a candidate. So here I1, I2, I5, I1, I2, I3 and I5, we have this as a candidate 3. Okay, candidate. Next, it will take I1, I3, I5. So I1, I3, I5, when we take I1, I3, I1, I3 here, let us take I1, I3, I5, I1, I3. I1, I3 is there. I1, I5. I1, I5 is also there. I3, I5. When I take this frequent item set, I3, I5. I3, I5 is not there in the frequent item. That means what? I3, I5 is an infrequent item set. According to the a priori principle, if the item set is infrequent, then its superset is also infrequent. That means what? I3, I5. What is the superset of I3, I5? I1, I3, I5. Obviously, this also becomes infrequent. Then here this will not be the part of the C3. That's what we are applying the second step operation, that is pruning. We are removing the infrequent item. So by using the pruning, a priori priority, okay, a priori property, sorry, a priori property. So same with I2, I3, I4. So the subset of I2, I3, I4 is I2, I3. I2, I3 is there. Yes, it is there. Then I2, I4 is there. I2, I4 is also there. I3, I4, I3, I4 is not there. Okay, not there. Then I3, I4 is infrequent. Then the superset is also infrequent. So that's why it is removed. Okay, that's why it is removed. Okay, similarly, here also the case. I3, I5 is not there. Then it is infrequent, removed. So in this case, I2, I4, I4, I2, I4, I5. I4, I5 is not there in this L2. It is not frequent. Then obviously this superset will also be infrequent. Then we remove this. So out of all this, we using the a priori property, we are removed the infrequent item set. We have pruned out the infrequent item set. So the candidate 3, that means 3 item set will be I1, I2, I3, I1, I2, I5. Got it? Hope you are understanding this. Okay. So that's the reason we have uh, like this. Okay, out of 6, using the a priori property, we filter out this, pruned out this, and we got this. Next, we have to find the support count I1, I2, I3. Okay, we will be having the support count of 2 from the original database. So we have to again check whether it is having a minimum support. Both are having the minimum support count. So both will be selected, L3. Now what we will do, we'll join L3 and L3. Okay, we'll join L3 and L3. So when we join L3 and L3, we'll get I1, I2, I3, I4. Yes or no? L3 is having I1, I2, I3, I1, I2, I5. Okay, so we'll get I1, I2, I3, I4. So when we take the original database, okay, when we take the original database, there is only one transaction which is having this combination I1, I2, I3, I5. Okay, the count is 1, support count is 1. So support count is less than minimum support, then means it is infrequent. So we didn't get the candidate C4. Okay, candidate C4 we didn't get. C4 is null, so we stop here. Okay, we stop here. So here, this is the explanation here given here. Okay, so when we join L3, L5, we'll get this. The support count of this is 1, which is less than the minimum support. So it is not a frequent items. Or using the pruning also we can say. Okay, because I2, I3, I5 is infrequent. Obviously, superset is also infrequent. So C4 is null. The algorithm terminates, having found all the frequent items. This completes our a priori algorithm. Next, what we have to do, we have to find the strong association rules. So now, what are the frequent item sets we have? We have to generate the association rule, we need the frequent item set. So what are the frequent item set we have generated from the previous steps? So we have that is L. L means frequent item set. So L1, L2, L3. We stopped up to, we did up to L3. Then we didn't proceed because C4 was null. So what are the frequent items we have? I1, I2, I3, I4, I5. Then I1, I2, I1, I3, I1, I5, I2, I5, I2, I4, I2, I5, I1, I2, I3, then I1, I2, I4. These are the frequent item sets. Okay, please remember, these are the frequent item set. First, we generated the frequent item set. Okay, the first step in the association rule mining is to generate the frequent item set. Came to know how we are generating the frequent item set. Okay, next, what we have to do, we have to generate the association rule. Okay, association rule. So association rule will be of this kind. Okay, so if frequent item set is L, okay, then generate all non-empty subset of L. For every non-empty subset of subset S of L, for every non-empty subset S of L, output the rule in this form: S tends to L minus S. Okay, if support count of L divided by support count of S is greater than or equal to minimum confidence. So what is the minimum confidence given? If you remember, it is 70%. Okay, minimum confidence given for this problem is 70%. So we have the frequent item set. Okay, we have the frequent item set here. Next, what we have to do here, when we have the frequent item set, we have one frequent item set, we have the two frequent item set. Yes or no? So here, most interesting patterns we say. So we have here one frequent item set, we have two frequent two item set, frequent three item set. Three means what? Three different items. Two means what? Two items. One means only one item. Okay? Like this. So even though we have this many frequent item set, to generate the association rule, okay, association rule, we will be taking the high level item set. Okay, that meets the support requirements. Okay, that is the high level. Among this, the high level item set is the three item set. Okay, that is meeting the high level item set that meets the support requirement is three item set. Yes or no? We have this one item set, two item set, and three item set. Okay. Out of this, okay, out of this, the highest level item set that meets the support requirement is the three item set. Okay. So that's why we, to generate the association rule, we consider this item set, three item set. Okay, hope you are understanding. Okay, here this is also frequent item set. This is also frequent item set. This all these are frequent items. This is also frequent item set. Okay, but what I am telling, to generate the association rule, we consider highest level item set. Which is the highest level item set here? 3 item set. Suppose if there was one more I1, I2, I3, I5, like that 4 item set, I would have considered that to form the association. Okay, so first we have to take this. Okay, we consider this 2 item set to generate the association rule. Let's see how it is. Okay, how to generate the association rule. So now the second step, generating the association rule from frequent item sets. Okay, please remember the minimum confidence given is 70%. The resulting association rule are shown because like we have taken 3 item set. So I1, I2, I5, I1, I2, I3, 2 are there. Okay, first I have taken I1, I2, I3 into consideration. I1, I2, I5 into consideration. Okay, these 2 items we are taking into items that we are taking into consideration to form the strong association rule. So first I'm considering this one, I1, I2, I5. So I1, I2, I5, when I can just take the rule line. If I1, I2 items are purchased together, then there is a chance that purchasing I1, I5 also. So I'll form a rule like this. Rule 1, I1, comma I2 tends to I5. So we have to find the confidence of this. What is the formula of confidence? Support of I1, I2, I5 whole divided by support of I1, I2. Okay, is it clear? That is support of X. We have the rule like this now. X tends to Y. X tends to Y. Okay, so if X tends to Y, so here we have the confidence that I1, I2, I5. Okay, so X is nothing but X tends to Y. What is the formula? The support count of X union Y whole divided by support of X. So what is support count X union Y? I1, I2, I5. So support count of I1, I2, I5 whole divided by I1, I2. Okay, I1, I2. So what is the support count I have given here? What is the support count of I1, I2, I5 is 2. What is the support count of I1, I2? 4. 2 by 4 is equal to 50%. Okay, is this 50% is greater than or equal to 70%? No. So R1 is rejected. Similarly, I'll take I1, I5, all combination of I1, I2, I5. Okay, so I1, I5 tends to I2. So I'll get 100%. That means it is selected. I1, I2 tends to I1. So I'll find the confidence. I'll get 100%. It is selected. Okay, it got selected. Then next I'll move on to another combination. So here I'll take in a reverse order. If I1 is purchased, then there is a chance. How many percent of chance that I2, I5 is purchased? Only 33% using the confidence formula. So it is rejected. If I2 is purchased, what is the chance of I1 and I5? It is 29%. So rejected. If I1 is purchased, what is the chance of purchasing both I1 and I2? It is 100%. Okay, you can see the count and all calculation. So R6 is purchased. So in this way, we have come up with the 3 association rule. That is, I1, I5 tends to I2. If I2, I5 is purchased, then there is a chance, 100% chance that I1 is also purchased. I5 is purchased, then I1, I2 is also purchased, 100% chances there. So this is a strong association. Okay, this is how we have to do. So first we found the frequent item set, and then using the frequent item set, that is the highest level of frequent item set, we generated the association rule. So this is about the a priori algorithm. So here is one exercise problem. You can solve this and tell me the answer in the next class. Thank you.